Okay, so the video here that we're going to walk through is just the one part of two, which would be converting between rectangular and polar equations. So you see kind of the examples on that first page there that if you're converting between the two different forms, then notice your equations are going to look a little bit different. So in some cases, they look a little bit more simple, they are more recognizable. In other cases, not so much. So you see the two that are in blue there are for that circle that's there in the page. Both of those pretty simple. You should be kind of used to thinking about things in terms of um, x's and y's for equations in rectangular form, and then for r's and thetas in terms of equations that are in polar form. So we're going to do two examples here. The first example we're going to look at is going from rectangular to polar. So is the second example. But you can see the two different types that are here. So what do we need to solve? Anytime that you're trying to convert it over to polar form, you're going to want your equation to be something r equals something in terms of theta. So there's going to be three basic steps to that. Now that is kind of making this a little bit oversimplified, but here's kind of the thing that's going to guide us as we go through the two examples. First off, the nice thing is your first step's going to be the same for all of these. If you have it in polar and you want to get it in rectangular, you're just going to start by substituting in r cosine theta for x, r sine theta for y. Your next step is going to be solve for r. That's the part that's going to be quite a few steps along the way, but you're just trying to isolate r. So there's going to be some strategies you'll see here to help do so. And you may also need some identities. Really the only identity that you're going to see here is going to be the Pythagorean identity. So your sine squared theta plus cosine squared theta equals 1. There might be some other identities you need, but for the most part, the ones that you'll need for examples you're going to look at will just be Pythagorean identity, and that is it. So looking at the first example, you've got x minus 4 quantity squared plus y squared equals 16. Now, hopefully after doing conics, you recognize that's a circle. And more importantly here, I want you to be able to pull off the center and the radius as well. So your center is that h and k values, so it's going to be 4 comma 0. Radius there, you take the 16, take the square root of 16, you get 4. So you should really already know what this looks like back from conics. But what we want to do is get this over into polar form. So when you look at this, I'm going to just draw a quick little sketch here of what that graph looks like. That is supposed to be a circle. So just think of it as a circle. Center is at 4, 0, and you got your radius 4. So in a little bit, once we get this in polar form, what we should be able to do is graph that equation once we get it in polar form, check with that graph and make sure that they're the same. If they are, you've done a good job. If not, we have to go back and start over. So what I'm going to do is I'm just going to rewrite that rectangular equation one more time. But what we really want to do is get this over to polar form, right? So we're going to follow those 3 steps above. That first step is just going to say, okay, let's replace x and y with r cosine of theta for x and r sine theta for y. So if I do the substitution in there, I get r cosine of theta minus 4, quantity squared, plus r sine theta squared equals 16. So all I've done is just make that substitution like you see from, step 1 above. Okay, so step 2, we need to solve for r. Now we've got r's in a couple of different places. So this is really where we got several steps to solve for r. So first thing here is just go through and expand. So we've got some quantities to square. So I'm going to take that r cosine of theta minus 4, and I'm going to rewrite that, get 2 factors of that, 2 copies of that, so I can distribute. So we'll write each of those 2. That's there and make it a little bit easier to distribute. And I'm just going to keep writing the rest of the equation that you have here so that we can get to the distribution step. Okay. Then if you look, I'm going to take r cosine of theta, multiply times each of the next 2. So I'm going to get r squared cosine squared theta. Multiply that r cosine of theta times the minus 4. So I'm going to get minus 4 r cosine of theta. And I'm going to distribute the negative 4. So negative 4 times the r cosine of theta gets me another minus 4 r cosine theta. Minus 4 times the minus 4 gives me a positive 16. I'll square the r sine theta, so I'm going to r squared sine squared theta equals 16. Now here's where I need to start kind of grouping some things together. So I'm going to group together and look at those 2 things I have highlighted in yellow because I'm starting to see the cosine squared and sine squared. I've got some like terms to combine with the minus 4r cosine theta. And then if you notice, I'm going to go ahead and take away the 16 from both sides because that's going to give me 0 for both of those. So a little bit of rearranging here, and this one starts to go a little bit smoother. So I'm going to rearrange those things I have highlighted in yellow first because I'm starting to see that Pythagorean identity with those sine squared and cosine squared theta values. Then I'm going to go ahead and combine my terms that I have highlighted in blue. So you're just going to have -4r cosine of theta. Now, since I want to use that Pythagorean identity, those two parts that I have in blue there, I'm going to have to factor out the r squared. They both have a common factor of r squared. So if I pull that out, that will leave me with just the cosine squared plus sine squared theta on the inside. Then I'm going to go ahead and just keep writing my -8r cosine of theta equals 0. So all of that on the inside really just equals 1. So I can do that substitution for my Pythagorean identity, just take out that whole expression inside the parentheses, just replace it with 1, and rewrite my equation. So the 1 times r squared is just going to give me r squared. So then I'll have r squared minus 8r cosine of theta. Now here's where I have to go back to algebra a little bit, algebra 1, algebra 2, do some more factoring, because I've got to solve and set this equal to 0, or I already have it equal to 0. So I need to factor this, because factoring this will allow me to set each of the two factors equal to 0. So each of those factors, each of those terms I should say, has a common factor of r. I'm going to pull out. Then I can take each of these two factors and set them both equal to 0. Both of those two factors multiplied together gives me 0. So either one of them or both have to be 0. Well, let's say I set the first factor equal to 0. So if r equals 0, that's not very interesting. I need the equation of a circle. R equals 0 would just be a point. It would literally just be a point at the pole right there at the origin. So I'm going to take my other factor, since that first one wasn't very interesting, it's not what I need. Take my next factor, set it equal to 0, solve for r. That's what I need. So I have r equals, I add the 8 cosine of theta to both sides, I get r equals 8 cosine of theta. Now what you would need to do with that is to check your work, right? Graph that in polar form, go back and look and see that it's the same equation, same graph that we had in rectangular form. Okay, so once you've kind of seen the steps there, there's a little bit more algebra that's involved here, and you're going to see that kind of play out on this second example as well. But hopefully this one feels similar to the first one, because it's really going to be the same steps to kind of get started, just a little bit shorter algebra steps to actually get this one going. So if I have y equals x squared, identify the graph, that's your basic parabola. Your vertex can be right there at 0, 0. And this is going to open up as well, because it's going to be a positive value. It's going to open up. So your quick sketch is going to look like this. So once we get to the end, once again, I want to be able to graph this in polar form and check and make sure that my graph looks something like the one I've just sketched there. So I'm just going to rewrite my rectangular form once again. And if you go back up to the top here and you think about those 3 steps, right? I got those first 2 steps, which are pretty standard. Okay, so substitute in your r cosine of theta for x. I'm going to substitute in r sine theta for y. So my new equation would be r sine theta equals r cosine of theta quantity squared. So I can simplify that a little bit. So I can square the r, square the cosine of theta. So I get r sine theta equals r squared cosine squared theta. Now I need to kind of get this similar to like those last couple steps in the previous example. So I'm going to set this equal to 0 so I can start to factor, because really I've got to solve for r. So the way I'm going to get those different r's together is by pulling out a common factor. So each of those, as I subtract the r sine theta over to the other side, I can pull out a common factor of r from each of those 2 terms. So on the inside, that leave me with r cosine squared theta minus sine theta. And you'll see the same thing play out once again. I've got 2 things multiplied together that give me 0. So one of them or both have to be 0. So if I let r equal 0, once again, not very interesting. It's a point. You're not going to need that factor that's there. I need a parabola. So that must mean that my second factor here must give me the parabola that I'm looking for. So I'm going to take that inside the parentheses. I'll have r cosine squared theta minus sine of theta. I'm going to set that factor equal to 0. And I'm going to solve for r. So first off, I'm going to start by adding sine of theta to both sides. So I have r cosine squared theta equals sine theta, and then I can simply divide by cosine squared theta. So my answer would be r equals sine theta over cosine squared theta. You can take that over to your graphing calculator once again, graph it, make sure that you end up with the graph that's up there above. And that's your examples for the notes of converting from rectangular to polar form. The big idea there is follow those steps that you have up above, There's going to be a little bit more algebra in these ones, but always in the end, get to your answer and then go over to your calculator in polar mode, graph it, and make sure that looks similar to the graph that you sketched at the very beginning.